So this first video is going to be the answers to questions 1 through 10 on the summer assignment. Hopefully you did the summer assignment and you just have a couple questions. You want me to go over some things. So the first question is all about significant figures. And yes, significant figures do play a role in any math problem. It's important to be able to look at a number and evaluate how many significant figures are in a value versus, and then be able to report out on the answer. So here we have the answers. There's no big deal. None of the rules are changed. Zeros to the left never count. Zeros to the right only count when there's a decimal. So that's why this one has 4. Well, these three don't count because they're to the right, but there's no decimal placed down. Trap zeros always count, so that one's good, and this one's good. And these two are trapped between the 1s. Those two are trapped between the 2 and the 6, so they all count. That's a trap 0, so there's 3. That 0's to the right and doesn't count because there is no decimal. So every answer you have to decide, how many significant figures should be in the answer, and when you write it, you have to write it with the right number of significant figures. In general, though, you don't have to use scientific notation in an answer unless it is an extremely large or extremely small answer. Like this answer here, this doesn't make any sense to be in scientific notation, nor does probably D here. That one doesn't really make any sense to be in scientific notation. When you get something like here, though, for E, minus the fact that it has 6 significant figures, usually you would not have 100 million or 600 million or whatever that answer is, 125 million written out longhand. You would use scientific notation to report that answer. One big key, though, in AP is your answer should have either the right amount of significant figures, that would be awesome, or it can have one more or one less sig fig than it's supposed to. So, for instance, in I, the answer to I is supposed to have 4 significant figures. You would not be counted off if you wrote this, because that only has 3 significant figures. It's supposed to have 4, but you're allowed plus or minus 1 sig fig in your final answer. Now, that point is a point that's taken out afterwards in the free response questions. It's not going to be assessed in the multiple choice, only the free response. Number 2, converting between units. You need to be really agile at being able to convert between kilo, milli, centi. Those are probably the 3 big ones: kilo, milli, centi, and of course whatever the base unit is. Occasionally you'll see micro, nano, or pico, so you might want to throw those in. Micro is 1,000 times smaller than milli, and then 1,000 times smaller when you go to nano, and then 1,000 times smaller when you get to pico. So make sure you review how to do unit conversions based on just the prefixes. Number 3 is a simple density question with a slight twist. You're supposed to figure out the volume of a 5-carat diamond. So you have a 5-carat diamond. It tells you that 1 carat is 0.200 grams, and then it gives you the density, and the density is in grams per cubic centimeter. Think about that as grams per cubic centimeter, and you could also write it as 1 cubic centimeter is 3.51 grams. You could write that as a ratio upside down. Now you've got the dimensional analysis set up for unit conversion: carats, carats, grams, grams, cubic centimeters. The answer has 2 significant figures. You're given as 2 significant figures. This is an equivalency, and anytime you have an equivalency with the number 1 in it, equivalencies with the number 1, you consider the 1 to be infinite. But on the other side, this is an estimate of 1, so that's 3 sig figs. And then here again we have per cubic centimeter, so that's considered to be an exact 1 infinite sig figs, and this is 3 sig figs. So of 2, 3, infinity, infinity, and 3, obviously 2 is the smallest, so we have 2 sig figs in our answer. Number 4, you do the math operations and express with the correct significant figures. Yeah, of course you should be able to type in your calculator, this times that. But then can you round it based on sig figs? Every once in a while there's something I don't like about a question. I don't like the fact that this question has no units. That really is bothering me right now, but it is what it is. This is what you had to do for the summer assignment. So, you just do the math and round it. Don't forget with adding, you're kind of looking at the number of place values that are considered significant. With B, 8.1, we don't know what comes after the 1. There's nothing written down, which is why we don't have anything after the first decimal place in our answer to B, because we don't really know what comes after that value. Same thing in F, where we're adding a bunch of values together. We have 2 place values after the decimal, 3 place values, 3 place values. So our answer can only have 2 place values. So we do addition, we do it the number of place values where the last farthest right estimated value is. Everything after this, and this number here, everything that's after this 7, we don't know what it is. The 7's an estimate. The number after an estimate's completely unknown. Number 5, number 6. Number 5, I should have given mass numbers. I apologize for that. I think I just used, when I did the answers down here, I just used the closest whole number. Like plutonium is 244 on the periodic table. So I should have given you, 244 here, and then these should add up. I don't know what happened to that. I don't know where those mass numbers went. Like that doesn't quite add up. That doesn't add up to that. So weird. But the math, this should be the summation of the protons and neutrons should be equal to the mass number. It doesn't work out for that one. Oh. Yeah, so these should have had mass numbers. So let's actually try this again. If this is 94 and 144, that would be, let's see, 238 for the mass number. So the mass number should have been given as 238 here. 2 and 2, that's 4. Where's that? Helium right here. The mass number should have been given so that you could deduce the number of neutrons. Number of protons, of course, you just go to the atomic number on the periodic table. Number 6, how would you expect the following atoms to gain or lose electrons when forming ions? In this scenario, we're looking at what's their common oxidation state. Oxidation state. Usually people say charge, but oxidation state is the proper term. It's how it gains or loses electrons to achieve a stable configuration of electrons. Sodium has 11 electrons. There's 1 extra valence electron in its outer shell, its valence shell. Tends to lose that 1 electron to drop down to 10, which is a stable configuration. We can usually figure this out real easily just by looking at the placement on the periodic table. Elements in column 1 tend to take a +1 charge. These guys take a +2. Aluminum on down, they take +3. Pretty much everyone's trying to gain or lose to be like the noble gases. There's 0, -1, -2, -3. And then we have all these oddballs in the middle. And those, you couldn't take a good guess on most of those. So we're usually given a Roman numeral to indicate how many electrons they've lost. There are a bunch of weird oxidation states out there. We're going to get into how to determine the oxidation state of an element in a non-traditional sense later on. But if you just have regular sodium, strontium, oxygen, you can use the periodic table to figure it out. Yes, you always get access to the periodic table. Naming rules. If you don't review anything else before school starts, review naming rules merely because they just come back over and over again. You should be able to look at this and go, okay, that's chromium, that's oxygen, it's going to be some sort of chromium oxide. Does chromium take an odd charge? Does it have a standard charge? Chromium in the periodic table is, again, it's in that area, the transition area down here. This transition area on the periodic table, the charges can be all over the place. So you have to determine the charge using what information you have there. So chromium, unknown charge, oxygen, there's two of them, and oxygen's oxidation state is almost always a -2. Well, chromium has to balance it out. There's one chromium, two oxygens, so this chromium has to be, that should be a Roman numeral 4. Oh, this chromium should be a Roman numeral 4 oxide, not a Roman numeral 6 oxide. I just got dyslexic there. So if this was a 4, it would balance out the oxygen, and the total ionic compound there would be neutral. Same thing with B. There's 3 oxygens. Each oxygen's a -2 charge, so 3 times 2 is -6. So the chromiums have to combine together as a +6. So if they're +6 and there's 2 of them, they are probably a +3. Hey, I did that one right. From there on, it's pretty easy. Aluminum's always a +3, so we don't put the Roman numeral in there. Selenium is right on the line for, no, it's a non-metal. We have a non-metal and a non-metal, so we use prefixes. We have 2 non-metals. We have a molecule, right? Because they're not exchanging electrons. They're sharing electrons covalently. Again, selenium's a non-metal, oxygen's a non-metal, so they use the prefix on oxygen. No mono on the first non-metal. No mono, triiodide. Sounds like an advertisement. Phosphorus is a non-metal, trichloride. Again, non-metal, use the prefixes. Number 8 is acids. Lots of polyatomic ions in this one, aren't there? We've got nitrate and its younger cousin with 1 less oxygen, nitrite. Difference between an 8 and an ite is the number of oxygens. The 8s always have 1 more than the ites. So this is phosphate, that's phosphite. There's phosphate, nitrate, sulfate. This is hydrogen sulfite. This is bromate, and this is periodate. And when you do the name for an acid, you have to change the ending. 8s become ic, so this is nitrate, so it's nitric. This is nitrite, so it's nitrous. Phosphate, right? Phosphate, phosphoric, that's kind of weird. The ic, 8, you get through the auric in there. Phosphite, phosphorus acid. This is not an acid, so we say the name of the polyatomic and the name of the metal. So we have sodium sulfate, calcium hydrogen sulfite, potassium bromate, ruthenium nitrate, etc., etc. There's a couple of polyatomic ions in the notes that you need to know. Most of them you don't need to. There's 118 total. You need to know like 7 or 10. It's not a lot. They're in your notes. Make sure you know those. More importantly, make sure you know how to name an ionic compound versus a molecule versus an acid. Those basic naming rules are paramount. And in reverse, writing a formula from the name. Quite often you'll be told names, then you have to write the formula, and then from the formulas balance an equation. If you have the wrong formula, you can't ever balance the equation. So knowing how to say, okay, this is cesium. Cesium is CS, and then bromide is Br. Bromine's a -1. This is a +1. Those charges balance. CS, Br. Knowing how to do that is key. And right along with that are the basic polyatomic ions like sulfate, ammonium, nitrate, phosphate, carbonate, acetate. Carbonates and acetates are super common. Phosphates, sulfates. I mean, those are the top ones there. And hydroxide. Oh yeah, hydroxide. So barium is +1. Sulfate is a -2. So you have the barium and the sulfate. When you see prefixes being pulled out, well, these are both non-metals, so they're using prefixes there to tell you what to do. Otherwise, the electrons are being exchanged in an ionic compound. So again, just practice, practice, practice. Make sure you know your nomenclature rules inside and out. All right.